Hey there. Today we are going to look at how we simplify square roots that don't come out to be whole numbers. So numbers that aren't perfect squares, we want to be able to simplify those for a variety of problems. So let's go ahead and take a look at a few examples here. So first off, let's go ahead and take a look at this right here. Let's have the square root of 18. Now we know that the square root of 18, if we put that in our calculator, would come out to be a decimal. So we need a way of simplifying things so that we don't end up with an infinitely long decimal that is hard to work with. So what we're going to do is we're going to take this 18 and we are going to split it up into two numbers that multiply to 18. You can use 9 and 2, you can use 3 and 6. It doesn't matter how you start splitting things up as long as you continue to split things up all the way down to the prime numbers. So I'm going to use 9 and 2. I see that 2 is a prime number. It can't get split up anymore, but 9 can be split up into 3 and 3. Once I have all of these are each prime numbers. So 3 is a prime number, 3 is a prime number, and 2 is a prime number. I don't worry about the 9 anymore. I don't worry about the 18. And so I'm going to rewrite the square root of 18 as the square root of 3 times by 3 times by 2. And what we are looking for is we are looking for a pair of the same number. We are looking for 2 of the same number here. So in this case, I see that I have 2 3s. So I'm going to circle those 2 3s. And what this is going to do is this is going to make 1 3 outside of our square root. Because 3 times 3 is 9, and the square root of 9 is a regular 3 with no more square root. This 2, however, can't be circled because there's no additional 2. And so that 2 has to stay inside of the square root. And so that just comes down. So square root of 18 will simplify to 3 square root of 2. And then you can go ahead and perform additional operations that might be listed in your problem, but this is how we simplify a square root. Let's take a look at another example here. Let's do the square root of 24. Once again, I want to split up the 24 into two numbers that multiply to 24. There's lots of different options. You could use 8 and 3, you could use 6 and 4, you could use 2 and 12. In this case, I'm going to use 6 and 4. I see here that both of these can continue to be split up. So 6 can be split into 2 and 3. And 4 can be split into 2 and 2. Now I see that all of these are prime numbers. 2s are prime, and the 3 is prime right here. Now, because I have a lot of numbers, I'm going to rewrite them in order from smallest to biggest. So I'm going to write all of the 2s first with the 3 at the end. So 2 times 2 times 2 times 3. Now, I only want to circle a pair. I only want to circle 2 of the same number. So I'm only going to circle 2 of these 2's because 2 times by 2 is 4, and we can take the square root of 4. But if we don't want to circle the additional 2 right here, we don't want to circle 3 2's when we have a square root. So this is going to make 2 in front of our square root. But then the 2 and the 3, neither of these can get circled. So both of these are going to come back inside of the square root. So 2 times by 3 is written inside. And if I simplify this, 2 times by 3 gives me 6. So this simplifies to 2 square root of 6. So 2 square root of 6 is the simplified version of the square root of 24. Let's look at one more example here, and this may be a little bit extra for some of you because not all of you may be dealing with imaginary numbers. But let's go ahead and take a look at what happens when we have a negative number inside of the square root. So let's say, for instance, that we have negative 12 inside of our square root. Now, what I'm going to do is I am going to split things up just like before, but I'm going to start by splitting up negative 1 and positive 12. And that's because negative 1 is treated a little bit differently when we are simplifying square roots. So I've split negative 1 off on its own, and now I'm going to treat this 12 just like I would have treated any of the other problems that we've seen so far. I'm going to split this 12 up into, in this case, 3 and 4. And then 4 can be split up into 2 and 2. I see that my 2's are prime, my 3 is prime, and then this 1 we're also going to include with things. So I have negative 1 times by 2 times by 2 times by 3. And as I said, not everyone may be dealing with this negative number here. This may be something that's a little bit extra for some of you. But we can circle this pair of 2's because we have 2 of the same number, just like we had seen on the last problems. We can also circle this negative 1 because this is going to give us something special, because the square root of negative 1 is equal to the imaginary number, or I. The 2's that got circled are also going to make a 2 outside of the square root. So I have I times by 2, and the square root of 3 will be with it as well, because the 3 did not get circled and it needs to go back inside a square root here. So the only other thing I need to do is I need to multiply the things that are outside. Well, I times by 2 is going to give us 2i. So we have 2i square root of 3. So anytime we have the square root of a negative number, that's going to give us an imaginary solution here. This I represents the imaginary number, and that takes care of the negative sign with the 12 here.